Okay, hi guys. It's 8:01, so I'll just start the webinar right now so that we can end on time. So thank you for taking the time to attend the Sec 2 webinar. The webinar will take about 1 hour. I will try not to exceed the timing. So the topics that I'll be going through today will be on quadratic expressions and equations, quadratic functions, together with a bit of graph question. So it's meant to be a quick revision for your WA2 because I understand that most students are actually being tested on algebra in WA2. So hope this will benefit you guys for your WA2. Okay, so the objective of this lesson is to use your algebraic identities to expand and factorize expressions or equations. Also apply the various methods of factorization. So I'll go through the various methods of factorization that you should have learned so far. The next objective is to express your algebraic fractions as a single fraction. So you have done something similar in Sec 1, just that in Sec 1, the denominators given to you will probably be just a single number. But for Sec 2, your denominators will be made up of unknowns as well. And the last objective of the webinar is to solve for quadratic and fractional equations. So this part over here is super important. These are essentially your algebraic identities that you have to know. So what I always recommend students to do as soon as they go into their exam or their WA is to like vomit out all the 3 identities on their paper first before they start doing the paper. Because if in the event, right, your brain fart and suddenly forget, then you will start panicking. And then if you panic, then you will ultimately not like perform as well as you expect. Okay, so these 3 identities, vomit it out as soon as the teacher say you can start your paper. Then just a quick note that this is a very common mistake for Sec 2s. So please note that this, which is your identity, is not equal to this. And this, which is also another of your identity, is not equal to this. So before I jump into the question, I want to go through the methods of expansion and factorization that you should already know by now. So for factorization, there are essentially 4 different methods that you should know. Yes, we will be sharing the PDF with you guys, but it will only be after the session. So what you can do is you can take a picture of like the questions on screen, or either that, or you can wait for us to release it. We will probably be sharing the recording together with the PDF for the student copy and the solutions next week. Yeah, so I hope that answers your question. So for factorization, you learn 4 different kinds of factorization. The first being your simple factorization. What is simple factorization is essentially the factorization you learn in Sec 1, where you find out what is the HCF, or sometimes also called the GCF, highest common factor or greatest common factor, throughout your entire expression or equation. So this is essentially the factorization you learn in Sec 1, is the most familiar form of factorization. The second method of factorization is what you learn in Sec 2, that is going to be your identities. So you learn the 3 identities, which is what I listed in the table above. We are looking at these 3 factorized forms. The third form of factorization is your cross factorization. So for clarity's sake, right, what the cross factorization is essentially this table thing that I'm talking about. And the last form of factorization will be your grouping. Okay, so for the identities, usually we only use identities when there are 2 or 3 terms. For cross factorization, usually we only use it when there are 3 terms. And for grouping, we only use it when there's usually 4 terms. But just take note that this is just a general guideline. It's not always the case. It really depends on the kind of question that your teacher set. So there are certain cases whereby there are 4 terms in your expression, but you don't use grouping to factorize it. You use like cross factorization already after you apply identity. So it's just a general guideline that if you get like 2 or 3 terms, then maybe you can try using identities first. Or you get 3 terms, you can try using cross factorization first. Or if you get 4 terms, you try to do grouping first. But essentially, if the general guideline doesn't work, then you have to go and try, maybe if you get 4 terms, you try doing cross factorization if grouping didn't work. Okay, so general guideline, don't just stick to like what I just wrote here. Okay, so those are the 4 methods of factorization that you should know. For expansion, there are just 2 methods. The first being your rainbow method. This is what you learned in Sec 1. We also use the exact same method for Sec 2. And the second is using your identities. Okay, so I'm going to go over to the first question where we want you to expand out this expression. So there's actually 2 different methods of expansion. I will go through both methods. The first method is what I think most students will actually do as soon as they see this expression. They will expand this left-hand side and this right-hand side separately. So that's what I'm going to do. So the first part of the expression is actually using your identity number 1, where I expand it out into a squared plus 2ab plus b squared. So I have a squared plus 2ab plus b squared. So I'm just going to fill up my ab into those brackets, and my a in this case is the 2x, my b in this case is the 3y. Sorry, why did I write a b here? This is supposed to be squared. So that's the expansion for the first part of the expression. The second part of the expression is where some students will make a very common mistake. So I'm going to highlight that in my highlighter later on. So the second part of the expression is I need to subtract the entire expansion at the back. I need to subtract the entire expression at the back. Here's where students tend to make mistake. The negative, right, at the front of the bracket actually applies to the entire expansion at the back, but students don't put brackets, and then the expansion only applies to the first term of their expansion, which is wrong. So that is a very, very common mistake. So just take note of that common mistake. So for my second expansion, I'm using the second identity where I expand it to a squared minus 2ab plus b squared. So I have a squared minus 2ab plus b squared. So just fill up your a and b's into the bracket. And in this case, my a is the 5x and my b is the 2y. So like I mentioned, the common mistake that students do is they forget to put in this bracket. This negative sign applies to my entire expansion on the right. If you don't put a negative sign, essentially your answer is going to be wrong. Okay, so now I'm going to expand out the entire expression to get 4x squared plus 12xy plus 9y squared. For the back part, I'm going to expand out first. And I'm not going to expand out this negative sign. So I'm going to just simply expand out whatever is inside the bracket first. So I do the expansion one by one to avoid any careless mistakes. From here, then I'm going to expand out this negative to the entire bracket on the right. And finally, the last step is just to simplify the entire expression. So simplify just means you need to combine all your like terms together. So the like terms I have will be this 4x squared together with this negative 25x squared. this positive 12xy together with this positive 20xy. And finally, this 9y squared together with this negative 4y squared. That's your final answer. Okay, so this is method number 1. For some of you guys who are like really good with your identities already, right? You will have noticed right from the start that the expression given kind of looks like your third identity, where you have a squared minus b squared. This is your entire a squared. This is your entire b squared. So you can also use the alternative method. I'm going to write the alternative method at the bottom. Just give me a moment to copy the question first. So I'm going to use again the third identity over here to expand and simplify this question, but I'm using the a squared minus b squared. But this is the unlikely working that most students will give me, because most students cannot see that this is the a squared minus b squared. Or they would rather just expand out everything and then combine all your like terms like later on. So using the third identity, if I have a squared minus b squared, I will end up with a plus b times a minus b. So my entire a is this 2x plus 3y. I'm going to put that in first. And my b is this 5x minus 2y. Common mistake over here is you need to subtract your entire b. So you must make sure you have brackets for this b such that your negative will apply to the entire 5x minus 2y. So just take note of the common mistake. Okay, from here, I'm going to simplify what I have within each bracket first. And then finally, expand using rainbow and simplify your final answer. So please don't leave this as your final answer, because you can further simplify the entire expression by combining these two center terms together. Wait, I think I have a careless somewhere. Oh yeah, sorry. Okay, my expansion over here, this should be positive because it's positive 3y minus 2y. So it should be positive y. That means to say that's going to affect the last two expansion over here. This should be negative 3xy. And this should be positive 5y squared. So again, combining these two like terms together, this will give me positive 32xy plus 5y squared. So regardless of which method you use, you will arrive at the same answer. Okay, then I'm gonna move on to the next question. So I'm gonna expand and simplify this expression as well. So for the first part, essentially you can't use any of the identity, just go ahead and use your rainbow method. So some students tend to just straight away draw all the rainbow first, right? But I wouldn't recommend that because sometimes when you draw everything, right, you are not keeping track of what you have expanded already. So each time you draw one rainbow, you write down that multiplication first, then you proceed on to draw the next rainbow. So that is the expansion for the front part of my expression. For the back part, same thing. The common mistake is this negative applies to my entire expansion at the back. So when you expand out the back part, please remember to include your brackets. So some students will just go ahead and do the rainbow method. Not wrong, but stronger students who can straight away identify that this is actually one of the identity. If I were to rewrite this as P plus 3Q, essentially what I have here is A minus B times A plus B. So that is your third identity. A minus B times A plus B. So when you expand that out, you can straight away go into A squared minus B squared. So I'm going to use that identity to expand A squared minus B squared, where my A is the one in front of the negative sign. So that is going to be P. And my B is the one behind the negative sign, which is 3Q. Next step, I'm going to concurrently simplify the front part of the expression first by combining this term together with this term. And for the back part of the expression, I'm just going to expand out the power. Next step, I'm going to open up the brackets and I'm going to combine all my like terms together. So for my PQ term, I only have one. I'm just going to transfer that to my final answer. For my Q square, I have negative Q square and positive 9Q square, which will give me positive 7Q square. And for my P square, I have 15P square minus P square, which will give me 14P square. That's your final answer. Okay, I'm gonna move on to the next question already. Please let me know if you need me to slow down or you would like some time to copy. You can just type it in the, I think it's a Q&A section. Otherwise, I believe that you guys are following me. I'll just move on. Okay, next kind of question. So just now we did expansion and simplification. Now we are going to do factorization. So if you remember, right, just now I mentioned at the start, that there are 4 methods of factorization that you have learned so far. The first method that you should always use is simple factorization. So even if you don't use simple factorization as the first method of factorization, you will use it like at the end. But most of the students forget to do simple factorization at the end if they do it at the start. So the easiest way is to get it out of the way first by always doing simple factorization first. Okay, so I have this expression which I need to factorize. to go and identify what is the HCF of all three terms, essentially you have three coefficients, 196, 36, and negative 168, right? Now, which is the smallest number? In this case, it's going to be 36. Go and list down what are your factors of 36. That's going to be 1 times 36, 2 times 18, 3 times 12, 4 times 9. I believe that are, and 6 times 6. So essentially, in order to find out what is the HCF of these three numbers, you just need to go and try to divide 196 and 168 by the factors of 36. So you start with the biggest factor of 36, which is 36. So you type in 196 divided by 36, you get a not whole number. That means to say 36 is not a factor of 196. Then you continue down the list, divide by 18. It's still not a factor. Continue down the list, divide by 12. Still cannot. You divide by 9. Still cannot. You divide by 6. Still cannot. Okay. I managed to take 196 and divide by 4. So possibly I can factorize out 4 from all three terms. So go and check whether 4 is a factor of 168 as well. And in this case, I take 168 and divide by 4, I get 42 as the answer. Meaning to say that you can factorize out 4 from all three terms. So take out the 4, put it at the front. What you'll be left with is going to be 49a squared plus 9b squared minus 42ab. From here, right, when there are three terms, some students will go straight into cross factorization. You can go ahead and do that. Or some of you guys who are really good with your identity, straight away you tell me, Cher, this is a perfect square. This is also a perfect square. I can use either identity number 1 or identity number 2. You are right. So I'm going to rearrange the terms such that it's easier for you to see that you can use the identity. So over here, I have two perfect square terms, and my middle term looks like it's somewhat made up of the two perfect square terms because it contains the A, which is part of your first perfect square term, and it contains a B, which is part of your other perfect square term. So which identity do you use? Since my middle term has a negative, you're going to use your second identity with a negative for this middle term. So I'm going to use the identity to help me to factorize this. But first, I need to express my two perfect square terms as a power of 2 first. So I'm going to replace everything with a brackets. Essentially, my brackets just represents the A and the B's in the identity. I believe some of the school teachers actually want to see this form first before you go straight into the factorized form. So now I'm just going to fill out what is in my bracket. I need to square root this entire perfect square term, and that's going to give me 7a. I also square root this entire term. This will give me 3b. So what is going to go into this two middle bracket? Using the identity, you know that it's going to be a and b. So just copy this into the first bracket and copy this into the second bracket. Then just do a quick check that when you expand out this middle term, it actually gives you negative 42ab. In this case, it does, so I can go ahead and straight away factorize it into my second identity's factorized form, where I have a minus b to the power of 2. So my a is the 7a minus my b, which is 3b. Okay, so that's for the first question. Moving on to part B. Again, we always use simple factorization first. So the HCF for these two terms, I know that I can take out x because the x is in both of the terms. Then pick out the smaller of the two numbers. I have 3 and 48. So 3 is the smaller number. What are my factors of 3? It's just 1 and 3. So all you need to do is check whether 48 is divisible by 3. In this case, it is. Meaning to say you can factorize out a 3 as well. All you'll be left with is going to be 1 minus 16x squared. From here, don't just stop. You can actually use your third identity where you have a squared minus b squared to further factorize it into a plus b, a minus b using your third identity. So I'm going to rewrite my two terms inside the bracket as a power of 2 first, since I know they are perfect squares. So if I were to square root 1, I'm just going to get 1. And if I were to square root 16x squared, that's going to give me 4x. Now I'm going to express my a squared minus b squared in the form of a plus b times a minus b. Just take note that it doesn't matter whether the a plus b comes first or the a minus b comes first, because multiplication is cumulative. So a plus b times a minus b. Okay, so that is for part B. Moving on to the next question. So for part C, if you have 4 terms, if you recall, the general guideline is if you have 4 terms, the first method you should consider will be grouping. So natural instinct is that students will tend to group the first 2 terms together and the third and fourth term together. So let's try to do that, okay? I group my first 2 terms together and I factorize out the highest common factor. That is going to be x squared y. And that will leave me with 1 minus y for my first group in blue. And for my second group, essentially, I cannot factorize out anything. I'm just going to leave it as x plus 1. Then you get stuck here. You're like, sure, my first group and my second group got no common factor. My second group essentially is just x plus 1 as the factor. I have no common factor that I can further factorize out. So don't just stop there, regroup everything. You can rearrange the terms if you don't find anything common that you can factorize out between your 2 groups. So that means to say this first grouping doesn't work. Try to rearrange your terms and see if you can find a common factor between both groups. So I'm gonna group this term together with this term, and this term together with this term. So this is my first group in pink. This is my second group in blue. So first group, probably most students be like, no problem, can factorize out. I just take out an x. I'll be left with xy plus 1. Then my second group is like, sure, how to factorize? So if you cannot see, that means to say you need to go and practice your identities. This is actually your a squared minus b squared. So if I were to rearrange this second group and put my plus 1 at the front, you have your third identity where you have a squared minus b squared. So when you have your a squared minus b squared, you can factorize it into your a plus b times a minus b. So your a in this case is just going to be 1. Your b is, if you square root this entire term, you will just have x times y. So a plus b, a minus b. So now comparing your 2 groups, there is a common factor between the two groups, and that is going to be this xy plus 1 factor. So I'm going to factorize that factor between both groups. Whatever I'm left with after factorization is going to go into my second bracket. So from my first group, after I factorize out the xy plus 1 factor, I'll be left with x. And for my second group, after I factorize out the 1 plus xy factor, I'll be left with 1 minus xy. So from here, I cannot further factorize already. That's my final answer. So some students stop here and think that is the final answer. So take note, when we are dealing with factors, right, the operation that we want to see is multiplication. If there is any addition or subtraction sign, it should be either inside the brackets or all the way to the front because you factorized out a negative number or variable or term. There shouldn't be any plus or minus signs between brackets. Okay, moving on to the last factorization question. So again, 4 terms, natural instinct for students is to straight away do grouping. But if you notice, right, if I were to my first 2 terms together and my third and fourth term together, there is nothing I can factorize. So that means to say there's a hint that you need to rearrange your terms. So pick out the terms that there is something that you can factorize. So what students might end up doing is they group this term together with this term because they are like, I can factorize out a 2a from these 2 terms. And then they end up grouping the -1 and the plus b together. Okay, so let's try that. I'm going to rearrange. And for my first 2 terms, I take out a 2a. I'll be left with b plus 2a. For my second group, I'm just left with -1 plus b. They be like, I'm stuck again. I got 2 groups over here, but there's nothing I can factorize out from both groups because there's nothing that is common. That means to say that your grouping is wrong. You need to go and rearrange it and regroup the terms. So if I have a perfect square and you see a -1, hint, that you can use the third identity where you have a square minus b square. So keep a lookout for -1, -4, -9, all the negative perfect square numbers. It's a hint. So I just say that I'm going to group the -1 together with the positive 4a square because I can use the third identity. So that's going to leave me with 2ab grouped together with b. So the HCF for my first group is just going to be simply b. And for my second group, is going to be your a plus b times a minus b. So my a is going to be the square root of the entire 4a square. Square root of 1 is just 1. So I'll have 2a plus 1, 2a minus 1. Between the 2 groups, you can see that there's a common factor that I can take out, which is your 2a plus 1. So I'm going to factorize that factor out from both groups. For my first group, after I take out a 2a plus 1, I'll be left with b. That's going to go into my second bracket. And for my second group, after I take out a 2a plus 1, I'll be left with 2a minus 1. So it's going to be plus because the sign here is plus. So plus 2a minus 1. Okay, I'm gonna move on to the next question. Next question will be a little bit more challenging because it's the application of your identities. So they gave you the value of x squared minus y squared equals to 56 and x minus y equals to 7. They want you to find out what is 2x plus 2y squared. So remember, a common mistake as students do is straight away they write down that this is equals to 2x squared plus 2y squared. Wrong, There's a wrong use of the expansion. So if you were to expand this out, you need to give me a squared plus 2ab plus b squared. Okay, but I'm not going to expand that out. When you're given an application question, right, you need to somehow manipulate these equations given to you. So I know that x squared minus y squared is essentially my third identity, where I can factorize it into x plus y times x minus y. Why do I want to do that? Because the question gave me the value of x minus y, and I have a x minus y over here. So if I were to substitute in the value of x minus y, I'll have 7 times x plus y equals to 56, and I know that x plus y will be equals to 8. Like, I can use this to answer this question. And you see a 2x plus 2y over here, I only have 1x plus 1y. What if I multiply both sides of the equation by 2? I expand this out, I will get 2x plus 2y. Right hand side, 8 times 2 will just give me 16. Now I have the value of 2x plus 2y. Substitute this value back into the question. And this will be equal to 16 squared, which will give me 256. Okay, so part A is still pretty straightforward. Part B is the one that is a little bit more challenging. I'll just copy the part B to the top because it's a little bit too far below. So part B, what we are looking for is 4xy. Then you look at your identities, right? You are like, got 4ab, man. Where in the world is the 4ab? Maybe I don't need to look at identity number 3 because there's no ab anywhere. I only need to look at identity number 1 and identity number 2 because the ab is like here and here. They are like, which one do I use? So I already have the value of x plus y, which is equals to 8. That's from this step over here. X plus y is equals to 8. So you can make use of this by squaring both sides such that when you expand out the left-hand side, you get a 2ab. Then from here, you're like, sure, but I cannot get rid of the x squared plus y squared. Question gives me x squared minus y squared, not x squared plus y squared. Then you already, then you're like, okay, never mind. I try to expand out x minus y squared instead. So question got tell me that x minus y is equals to 7. So x minus y equals, x minus y, why did I write 7? X minus y equals to 7. That means to say if I were to square both sides, this will give me x squared minus 2xy plus y squared equals to 49. Like, I still get the same problem. I got square plus y square. I want to get rid of it. Question only give me x squared minus y squared. Then what if you compare these two equations? What I'm looking for is 4xy. If I were to find the difference between these two equations, The difference between my x squares is 0. The difference between my xy is 4xy. And the difference between my y squared is 0. So you have learned simultaneous equation already. If I were to take equation number 1 and subtract away equation number 2, essentially the left-hand side will be equals to 4xy. So I'm going to write that down. So equation number 1. So if you're not able to solve such questions, you just need a bit more practice. The application question can be a little bit more challenging. So I have the left-hand side of my equation number 1 minus away the left-hand side of my equation number 2. Then I'm going to write the right-hand side of equation number 1 minus away the right-hand side of equation number 2. Expand out the second bracket. So I realized I got typo. It's supposed to be 49. Right, 7 squared is 47. So the difference between 64 and 49, that's going to give you 15. On the left-hand side of your equation, essentially your x will cancel out with your your x squared will cancel out with your x squared, your y squared will cancel out with your y squared. All you're left with is going to be 2xy plus 2xy, which is 4xy. And this is equals to 15. So answer for part B, 15. Yes, sorry. I also just saw that 7 squared is 49. Thank you for highlighting that. Okay, I'm gonna move on to the next question, where we need to combine two different fractions into a single fraction in its lowest term. In its lowest term just means to say you need to simplify. So whenever you need to combine fractions together, you always need to factorize your denominators first so that you can identify which are your repeated factors. So I need to factorize out my first fraction's denominator and second fraction's denominator. First fraction denominator, if you notice, is your third identity where you have a square minus b square. So factorizing that out, I'll get a plus b times a minus b. Second fraction's denominator, I can factorize out a 2. Comparing the denominators, you notice that one of the factor is repeated in both denominators. So that means to say that you only need to multiply your first fraction by 2 and your second fraction by this other factor 1 minus x. So I'm going to straight away do this multiplication to give me 6. Over the LCM of your denominators, which is going to be 2 times 1 plus x times 1 minus x. Minus away your second fraction's numerator is going to be 6 times 1 minus x over that same LCM. I wouldn't recommend you to expand and then combine, because students tend to make the mistake when they bring this negative sign up into the numerator. So I will advise you to combine the numerators first, and then you expand. So from here, it's just your set 1 expansion already and your simplification. So remember the question say you need to leave it in the lowest term, right? That means to say you have to simplify your final answer if possible. In this case, I can actually divide numerator by 2 and divide denominator by 2 to get this as the final answer. Okay, gonna move on to part B. So for part B, the first fraction is already factorized for the denominator, but the second fraction is not. So please factorize out your second fraction's denominator first. I'm going to concurrently bring this negative sign up to the numerator. Some students straight away tell me, I can cancel this q minus 4 with this q minus 4. You cannot do that because it's not a multiplication sign between the fractions. So you can only do that if it's a multiplication sign. If it is not a multiplication sign, please do not cancel like that. Okay, so factorize my denominator already. Go and find out what is the LCM of both of your denominators. In this case, I have one of the factor that is being repeated, which is the q plus 2. So that means to say my first fraction needs to multiply by 2 on top and below. And my second fraction need to multiply by q minus 4 on top and below. So now your denominator will be the LCM of both denominators, which is 2 times q minus 4 times q plus 2. Then if you notice your second fraction's numerator is actually your second identity. So if some of you guys are able to see that, right, straight away you can rewrite your second fraction's numerator as q minus 4 square, then use your identity to expand out later on. So remember I mentioned that you combine your numerators first before you expand. And the common mistake that I mentioned just now is when you have a negative in front, your negative applies to the entire expansion at the back. So make sure you include brackets when you expand this q minus 4 square. So I'm using the second identity to expand this out. Finally, expand out your numerator and simplify your numerator. Okay, here's the thing. So most students will actually just stop here and tell me that this is the final answer. So always do a quick check to make sure that if I were to factorize my numerator, there is nothing else I can cancel on the numerator and denominator. So to do a quick check when you have a quadratic expression, right, you can use your calculator, the menu, then press 5, then press 2, polynomial. The degree for a quadratic is just 2. Type in your coefficients of your quadratic term, linear term, and constant term. What your calculator is going to give you is going to be x1 is equals to -2 and x2 is equals to -8. If you were to unsolve for x, your x1 plus 2 will be equal to 0 and your x2 plus 8 will be equal to 0. So essentially your two factors for your numerator is x plus 2 and x plus 8. Do you notice that x plus 2 is essentially the same as q plus 2? Meaning to say you need to do an extra step to factorize your numerator. But please don't just use calculator to help you double check. To factorize your numerator, you can either use your identities or your cross factorization. So since I haven't used or shown you all the cross factorization, I'm going to use cross factorization to factorize my numerator. So I already got a hint from calculator that I need to create a q plus 2 as one of the factors. So using that hint, I'll put a q and I'll put a plus 2 here. Work backwards, that means to say my other factor that is going to go here and here is going to be -q and -8. Do your cross multiplication and make sure that you still get -10q. In this case, you do. So your two factors in numerator is going to be q plus 2 and -q minus 8. From here, you can cancel out that repeated factor on top and below. To arrive at a final answer of -q minus 8 over 2 times q minus 4. Some of you guys gave me the answer as -q plus 8 over 2 times q minus 4. Also can, they mean the exact same thing. Okay, I'm gonna move on to the next question. We need to solve for the equation. So when they mean solve, right, essentially all they mean is you need to go and find what is the value of the unknown. In this case, the unknown is x. So what some students will tell me is, sure, I can factorize out a negative from the right-hand side and swap the position of my 2x and my 3. Then, I got this factor on the left and on the right. I divide both sides by 3 minus 2x. You shouldn't do that because you'll be missing out on one of the answers. So if you notice, right, this left-hand side, if you were to expand out, you'll get a quadratic equation. And when you have a quadratic equation, that means to say you have up to 2 values of x. So if you divide both sides by 3 minus 2x, you are essentially removing one of your answers. So please do not do that. So expand out the left-hand side, expand out the right-hand side. Then to solve for quadratic, cubic, in future you will do cubic in A-Math, you have to move all the terms to the left-hand side and make your right-hand side be equal to 0. So I'm going to do rainbow to expand out the left-hand side. Right-hand side essentially is the sec1 expansion, also using rainbow. I'm going to further expand out the left-hand side, and I'm going to concurrently move all my terms from the right to the left so that I make my right-hand side be equal to 0. Combine all your like terms together. And since you have 3 terms, you do your cross factorization to factorize this equation. What I like to do personally is I don't like to deal with a negative coefficient for my quadratic term. So I will tend to divide the entire equation by -1. So I'm just going to reverse all my signs, but this is just a personal preference. You can don't do this as well. And I'm going to do my cross factorization with this left-hand side. So I know that my factors of 2x squared is just going to be 2x times x, but your 42 has way more factors. So please list down the factors of 42 if you cannot do it mentally. I believe these are all my factors already. So I will typically start from the top of the list and see whether this pair of factor will work. In this case, 1 and 42, if I were to put 42 here and I were to put 1 here, I can never get to 25. So I know that my first pair is out. Second pair, I have a 2 and 21. So if I were to put 21 here and I were to put a 2 here, it looked like it might work. So let's test it out. 21 here, 2 here. If I were to cross multiply, I'll get 4x and I cross multiply, I get 21x, right? They're like, this can give me positive 25x, but take note that there is a sign over here. The negative sign need to go to either of these factors. So if I were to negate either of these factors, I will not get 25x. So that means to say that this pair of factor looks correct, but it's actually wrong. So don't get tricked by that. So that means to say my second pair of factor is out. Try your third pair. Logically, I'm going to put the 3 below and the 14 on top because if I take 14 and times 2, it looks like it's going to give me a huge number. So logically, I will do this first. 3. Then I ask myself, 2 times 3 give me 6. 6 plus 14 will not give me 25. Try to swap the position and see if it works out. So some students only try one sequence. They don't switch the position. Do try to switch the position in the event that it actually works out. So if I were to cross multiply, this will give me 3x. Cross multiply, this will give me 28x. Then you're like, if I take 28 and minus away 3, I actually get 25. So this is where that negative sign is going to go. Since my final outcome is a positive number, that means to say the bigger of the two, it has to be positive. That means to say my negative needs to go to the 3. And the negative needs to come from this front part's multiplication and that's going to go to the 3 because my 42 has a negative. So my two factors are going to be 2x minus 3 and x plus 14. To solve for x, equate each factor to 0. Essentially, when equating each factor to 0, what you are doing is dividing one bracket to the other side, and 0 divided by whatever is 0. So you have x equals to 3 over 2 or x equals to negative 14. If your answer is an improper fraction without any alphabet, please leave it in mixed numbers or decimal. If the decimal is like too long, then please leave it in just proper fraction, sorry. Okay, moving on to part B, where you have fraction in the equation. So the quickest way to solve this, in my opinion, is to find the LCM, like what I did earlier on, right? When I have fractions in an expression, I go and look for the LCM of all my denominators. Same thing for equation. The only difference is that when I find the LCM for all my denominators in an equation, I'm gonna remove all the denominators after I multiply each fraction. I'll explain what I mean later on. So before I find what is the LCM, again, find what is the fraction's denominator in factorized form. So all I need to factorize is my second fraction's denominator. So I have essentially three different factors over here. X plus 3 is one factor, 2 is another factor, and x plus 2 is the third factor. Why do I not highlight this extra 2 is because I have a 2 here already. So the LCM of all my three fractions is going to be x plus 3 times x plus 2 times 2. I'm going to write that number at the front. So first fraction, to make my denominator this, I need to multiply by 2 times x plus 2. For my second fraction, to make my denominator from this to this, I need to multiply by x plus 3. And for my third fraction, to make my denominator from this to this, I need to multiply by the entire x plus 3 times x plus 2. So again, the difference between expression and equation is when I find out the LCM of all my denominators, I can essentially remove all of it already. That's the shortcut. So I'm just going to deal with the numerators now. This top part. So I have 2x times 2, which will give me 4x multiplied by the x plus 2 in blue, followed by negative 5 multiplied by x plus 3 equals to your x plus 3 times x plus 2. What you're left with to do now is just to expand everything, move all the terms to the left-hand side. There is the same routine, you factorize and you solve for x. For this back part expansion, I'm using rainbow. The front part, sorry, forgot to say, front part, I just use the set 1 rainbow method. From here, I'm going to simplify this left-hand side first by combining the 8x and the minus 5x. And then I'm going to concurrently move all these terms to the left. So just reverse the positive to negative and negative to positive. Combine all your like terms together. Then do your cross factorization for the left-hand side. So for the projected term, very straightforward. 3x squared, you can just split it into 3x times x because the factors of 3 is just 1 and 3. For 21, you have 1 times 21 and 3 times 7. So you need to test these two pairs of factors. But straight away, you look at the 1 times 21, right? If you put the 21 on top and you put the 1 below, regardless of, oh sorry, if you put the 21 on top and you put the 1 below, you can never get 2 because it's too far already. So that means to say your first pair is going to be out. You test for your second pair. If you were to put your 3 below and your 7 on top, you can get 9x and 7x. And you can take 9x and minus away 7x to get 2. But your outcome is a negative number. That means to say that the bigger of the two numbers need to be a negative, such that negative 9x plus 7x will give you negative 2x. So this negative sign needs to come from the multiplication at the front, and that is going to come from this 3 because your 21 has a negative at the front. So your two factors is going to be 3x plus 7 and x minus 3. To solve for x, equate each factor to 0. I remember if your fraction is like a standalone fraction without any algebra, please leave your answer in mixed numbers. Okay, it's 9:10 already, so I'll probably just go through one more question. Do try to stay to the end because we actually have a promo to share with you guys for those who yeah, we actually have a promo to share with you guys. So it's some discount for lessons. I believe I'll share the slide with you guys later on. Okay, moving on to the last question that I'm going to go through. So we actually have two more questions, but don't worry, we'll share the solutions with you guys. So you can attempt the other two questions by yourself and counter check with the solutions. There will be workings provided in the solution copy. Okay, for question 6, the diagram shows a quadratic function. So just so you know, the important things to take note for a quadratic function, right, is the coefficient of your quadratic term. This is your quadratic term. The coefficient will determine whether it is a smiley face curve or a sad face curve. So what you probably know is that if my coefficient is a positive number, then it's going to be a smiley face curve. And if it is a negative number, it's going to be a sad face curve. So in this case, since it's a negative number, we're going to deal with a sad face curve, which is also shown in the graph given already. The other thing that you should know is when your function is in expanded form, the constant term, which is this negative 28, this is essentially shortcut your y-intercept. So this is things that you should know already. So they want me to find the coordinates of A, B, and C. Coordinates come in the form of brackets. So don't just tell me X equals to what, Y equals to what. We are looking for a specific format. And since there are alphabets for each point, we are looking for A bracket something comma something, B bracket something comma something, and C bracket something comma something. So this is the format that we are looking for. So let's take a look at the graph given. My A and B are the x-intercepts of the graph. So at the x-intercept, one of the coordinate is definitely known, and that is going to be the y-coordinate of the graph. So the y-coordinate is definitely 0. Straight away, you can just put in the 0 for your A and your B. And this C is essentially my y-intercept. So at the intercept again, one of the value is definitely known. And at the C, since I'm looking at the y-intercept, my x is definitely 0. So you have a function with just two unknowns. To look for, let's start with C first. To look for the coordinates of C, I know that my x is equals to 0. One function, two unknown, of which you know that x is equal to 0, you can solve for the other unknown. So the function given is y equals to negative 2x squared minus 15x minus 28. When x is equals to 0, my y will essentially be equal to negative 28. Because anything multiplied by 0 will give me 0. So these two front part will essentially just be equal to 0. Therefore, you can conclude that the coordinates of C will be 0, negative 28. To solve for A and B, you know that your y is equals to 0. So again, you have one function where the unknowns are y and x. You already know that your y is equals to 0. So you can substitute in 0 into the function and you'll be only left with one unknown. To solve for that one unknown, you have a quadratic equation. You need to use factorization to solve. So since I'm dealing with an equation, I'm going to divide the entire equation throughout by -1. Again, personal preference, I just like to deal with a positive coefficient for my quadratic term. Another benefit of dividing everything by -1, right, is now you deal with all positive numbers. Because students tend to make mistakes with a lot of negative numbers. But take note, you can only do this with an equation. Don't do it with an expression. If you're dealing with an expression, you have to factorize out the -1. You cannot just remove the negative and change everything to positive. So I'm going to do my cross factorization. Again, very straightforward. Your 2x squared is just going to separate into the factors 2x and x. But your 28 has more than two factors. So list down what are your factors of 28. First pair, unlikely to be correct because wherever I put the 28 and the 1, it's not going to give me 15. So I can straight away strike out. That's for your second pair. No point putting the 14 here because 14 times 2 will give me 28. My other factor is 2. I cannot combine 28 and 2 to give me 15. So try to put your 14 on top, your 2 below. Then you think about it, if I were to cross multiply, this will give me 14x. Cross multiply, this will give me 4x. Not possible for me to plus or minus 14 and 4 to give me 15. So that means to say, this factor is also out. So your last pair, 4 and 7. I'm going to put a 7 on top and a 4 below. Cross multiply, I'll get 8x. Cross multiply, I'll get 7x. I can combine the 7 and the 8 to get 14 by to get 15 by adding them together. So that means to say this factor has positive sign. My quadratic and my constant terms earlier on are both positive. So everything here is positive, all checks out. That means to say my two factors are going to be 2x plus 7 and x plus 4. So to solve for x, equate each factor to 0. Go back to the question. If you remember, they asked for coordinates. So this is what I mean by don't just leave it as this as your final answer. You're not telling me what is the coordinate of the A and the B. So earlier on, I already concluded what is the coordinates of C. So I'm done with that. Please conclude what is the coordinate of A and B. So you don't just assign any number to the A and the B. Look at where the location of your A and B are. Since my B is closer to the origin, that means to say my B's x coordinate need to be the bigger number. The bigger of these two numbers is going to be the negative 3.5. So that means to say my B's x coordinate is negative 3.5 and my A's x coordinate is negative 4. So please conclude that in your final answer. Sorry, I meant to write a therefore. Therefore, A is negative 4, 0, and B is negative 3.5, 0. So that's part A. Part B, write down the equation. If we are looking for an equation, essentially a line of symmetry, we are always looking for the form x equals to something. Because a line of symmetry is essentially a vertical line. So in a vertical line, right, any point on that line, regardless of where I am, is always x equals to that particular value. The x doesn't change, which is why it's x equals to a number. So to find the line of symmetry is going to be right smack in between your two x-intercepts. So since it's in between negative 4 and negative 3.5, to find what is that middle value is just half of the sum of the two x-intercepts. So your two x-intercepts is negative 4. The sum means you plus. So you add them together and divide by 2. You'll get negative 3.75. Remember, question asked for equation. So we are looking at x is equals to negative 3.75. This is the correct format we are looking for. Okay, part C, last question I'm going to go through. Find the coordinates of your turning point. Turning point essentially refers to your maximum point, minimum point. They can be used interchangeably. So it can refer to your max point if it is a set face curve, which is what we have over here. Or it can refer to your minimum point if it is a smiley face curve. So what you need to know is your turning point essentially lies on the line of symmetry. That means to say that since I already know that my line of symmetry is x equals to negative 3.75, one of my coordinates of that turning point is already known, and that's going to be my x. So your job now is to go and find what is the y coordinate. Go back to the function. You have two unknowns, of which you already know that one of the unknown is negative 3.75. So to solve for the other unknown, just substitute this negative 3.75 into the function to solve for y. since my x is a negative number, I'm gonna first replace all this x with brackets to avoid any careless mistake. So I have negative 2 times x squared. I'm going to replace my x with just brackets squared minus 15 times x. I replace with another bracket minus 28. And now all I'm going to do is put in this negative 3.75 into these two brackets. Why I want to do that, right, is because some students, what they type into calculator to evaluate this front part, they type in negative 2 times negative 3.75 square. This is wrong. So just take note that negative 3.75 square is not equals to negative 3.75 everything square. One will give you a negative outcome, one will give you a positive outcome. That means to say your answer will be completely different from the actual answer. So now all you need to do is to type this entire thing in the exact form, including the brackets, into calculator. And calculator will give you 0.125. Do a sanity check. You have a positive value of y over here. My y coordinate for the turning point is on the positive side of my y number line, so should be correct in that case. If your sign is wrong, that means to say for sure wrong. So please conclude your final answer in the coordinate form. Therefore, coordinate of turning point is going to be equals to negative 3.75, comma 0.125. You can leave it in fraction form as well. Okay, so I hope you benefited from this webinar session. Again, we will be uploading or sending you guys the student copy as well as the copy with the solutions. The solutions includes the working. So you can try to attempt question 7 and question 8 by yourself and refer to the solution to double check your working of your answer. We will also be sharing the recording of the webinar with you guys, but everything will be shared, I believe, next week.